In this video, we discuss about bitwise left shift operation on a positive number. Here I have taken number 10 and the binary value of 10 I am representing it in 8 bits. Here is the value 00001010. Here sign value is 0, that means 10 is a positive number. Here I am performing 10 left shift 3. That means these entire bit values are shifted 3 positions to the left hand side. Now observe here, they are shifted 3 positions to the left hand side. Now what happens here? So whenever they are shifted to the left hand side, there are 3 empty places on the right hand side. These 3 empty places, they are filled with the zeros. The right hand side empty places are filled with the zeros. Now, as the register size is only limited, as it is now, I am representing it in 8-bit register. Now see here, 8 bits are completed and these are exceeding bits. These are the bits which are exceeding the register size. These bits are eliminated. These bits are not considered. Why? Because they are not fitting in the register. They are out of the register. So in this fashion, the excess bits are removed. Now this is the value here when 10 is shifted to the left hand side by 3 positions and the right hand side empty fields or empty spaces or empty places are filled with the zeros. Now we find out value for this particular one. In order to find out value, we use 2 powers. Why? Because this is the binary value. In order to get a decimal value, we use 2 powers. 2 power 0, 2 power 1. We write 2 powers for each and every bit value. And then for the sign bit value, as we are demonstrating an example for, I am treating it as a signed value. Signed value means it contains both a positive number and a negative number. For the sign value, we use minus symbol, minus 2 power 7 into 0, plus 2 power 6 into 1, plus 2 power 5 into 0, and so on. We write 2 power 0 into 0. So this minus 2 power 7 into 0, plus 2 power 6 into 1, plus 2 power 5 into 0, plus 2 power 4 into 1, likewise, and so on, plus 0 into 2 power 0. In this fashion, minus 2 power 7 into 0, it will become 0. 2 power 6 value becomes 64. And then 2 power 4 value becomes 16. And so on. And final value is 64 plus 16, that is equal to 80. In this fashion, the left shift operator works. In the previous video, we have demonstrated with a simple example. Whenever a value is shifted to the left hand side, its value becomes double for each and every position. When 10 is shifted for the first time, its value becomes 20, and for the second time its value becomes 40, and for the third time its value becomes 80. Here is the value, we got 80. And finally, one point, whenever we are shifting values to the left hand side, now we assume that now I am taking this value. This is the value 0, 0, 0, 1, 0, 1, 0. This is the value we have taken. Whenever we are shifting value to the left hand side, there may be a chance that in the sign value, in place of 0, we may get a 1. There may be a chance that in place of 0, we get a 1. Now what happens here? In the sign value, 0 means positive value. In the sign value, 1 means it is a negative value. That problem arises when we are shifting a value to the left hand side. Whenever we are performing left shift operation, there will be 2 problems that may encounter. One is the sign value might change. Second problem is if the values exceed register value, then we may get incorrect values. In both cases, we get incorrect values. That means a positive number may turn into negative number, or a negative number may turn into positive number. That happens when the sign changes. And the second problem is When the bit values exceed the register size, then we may get incorrect values. These things we need to consider, we need to remember whenever we perform left shift operation. In the next video, we discuss about the math behind bitwise left shift operation on a negative number.